In this particular video, let's see what covariance is, what correlation is, what is difference between covariance and correlation. Let's start. Firstly, before going to covariance, let's understand what variance is. As the name suggests, variance, it is basically how much a point varies from the mean of its sample. So let's say you have a sample. Okay, let's say there is a sample of population, and the feature which we are trying to calculate is weight of that sample population. Let's say we have 100 people in our sample and we are trying to calculate what the variance is. So variance of a single person will be basically his weight minus mean of the whole population, which is basically average weight of the whole 100 samples divided by 100 minus 1, which is 99. Okay, that is what variance is. Variance is basically xi, which is basically a point, minus x bar, which is mean, divided by n minus 1, and we take the square of xi minus x bar. Okay, so that is what the formula of variance is. Now let's see what covariance is. Covariance is basically how much two features are related to each other. Okay, covariance will just give us what the direction of the features is. If the covariance is positive, that means when feature 1 increases, feature 2 will also increase. If covariance is negative, it means when feature 1 decreases, feature 2 will also decrease. Weak covariance basically means feature 1 and feature 2 are kind of independent of each other. That is what weak covariance is. Formula for covariance is, let's say you have a feature in that sample of 100 people. A feature is weight and the second feature is height. Okay, so covariance will be basically how much is height and weight related to each other. Okay, and generally speaking, as the height increases, the weight also increases. There may be an exception to this, but in this case, the covariance is positive. Okay, so as the weight increases in our sample, height should also increase. The formula for that is xi minus x bar, which is basically weight of a person minus mean of the whole sample multiplied by yi minus y bar, which is basically height of the person minus mean of that height, and we divide the whole term by 99. Okay, okay, so we do this for the whole 100 people. We take the addition of it, of the multiplication, and then divide the whole term by n minus 1. So basically summation of this thing, which is a person minus the mean of first feature, a person's attribute minus the mean of that attribute of your second feature, adding it of the whole 100 population and dividing it by 100 minus 1, which is 99. That is what covariance is. Covariance can either be positive, negative, or weak. Moving on, let's see what correlation is. Covariance only gives us the direction. Is it positive, is it negative, or is it weak? Correlation will also give you a value. Correlation will also give you a value. And the formula for correlation is basically covariance of xy divided by multiplication of standard deviation of x, standard deviation of y. This is what a perfect positive correlation looks like, which is +1. This is a correlation of 0.9. This is relatively low correlation, which is of 0.5, although it is positive. This is relatively negative correlation, which is low with the value of 0.5. This is high correlation in negative, which is minus 0.9. Perfect negative correlation is -1, and the zero correlation is scattered vaguely. Okay, moving on. The important point to consider is while correlation coefficients lie between -1 to +1, covariance can take any value between -infinity to +infinity. That's all for this video. Thank you. Let's meet in next video.